Welcome back to the Lowdown on Physics. Today we'll be looking at projectile motion in two dimensions. This is part one, where we're looking at horizontal projection. And isn't that a sensational piece of animation? Okay, so forces acting on a projectile. The only force that acts is the weight force. We're ignoring frictional forces and air resistance. So the force is due to gravity. It's directly or vertically down. So that means the acceleration on a projectile is due to gravity. So it's always going to be acting vertically down. Value of -10 as per what your exam asks you to use. Magnitude and direction are independent of velocity. So regardless of, don't get confused by seeing the velocity pointing on an angle, G is always down. It only occurs in the vertical components. No horizontal G. No horizontal A at all. So let's have a look. Horizontal projection is what we'll look at first. And this is where it is launched horizontally. So it drives, a car drives off a cliff or a ball rolls off a table. So there's only an initial velocity in the horizontal direction. Let's have a look firstly at what happens to the velocity vertically down. Okay, so we've got constant acceleration, and that's due to G. That means that the velocity is continually getting larger the longer that it's in the air. The further that it falls, the larger that the velocity is. Notice the parabolic motion that it follows as it goes down. What happens to the horizontal velocity? Well, that's going to remain constant because we don't have any acceleration. So even though we're getting larger and larger steps each second as it falls in the vertical direction, the horizontal steps are always the same length. That's because there's no change in velocity. So the initial velocity and the final velocity in the horizontal direction remain the same. So let's have a look at a problem. How would we problem solve something like this? So calculating time of flight, let's have a look at the vertical motion. The one that's going to determine how long it takes is the one that's going to cause it to hit the ground. That's the vertical component. So it doesn't depend on horizontal velocity, so therefore it's totally about how far it's going to fall. So the initial vertical velocity is 0 because it's rolling off in a horizontal direction. Acceleration is G, so listing our variables. The distance it's got to fall is x, and I've put the subscript v, vertical direction. The time of flight is, well, that's what we're looking to work out. So we've got x, we've got a, we've got u, and we need t. So we can use x equals ut plus a half at squared. Little subscripts help me remember that I'm looking at the vertical direction. So we can now solve for t. So substitute in, u is 0, so that means that this whole part of our equation disappears. xv is going to be, well, whatever the value is there. G is -10, so it's actually going to be -10 times 0.5, which will become a half t squared. So time depends totally on gravity and the height that it's falling from. If we want to calculate the horizontal range, we want to know how far out it's going to land. We need to know how quickly it was moving to begin with, because that's how quickly it will move through the entire flight, and how long it took to fall down. Knowing both those things, we can work out how far it would travel in the horizontal direction. So we've got an initial velocity, we know t, horizontal acceleration is 0, so distance equals v times t. That's basically distance equals speed times time. If we look at this, this is the same as x equals ut plus a half at squared. But the acceleration is 0, so that last part of the equation goes to 0, that disappears. Okay, the terminology that we use for this, so that it would be x horizontal or subscript h, terminology we use is called the range. So if it asks you for the range, it means how far did it travel in the horizontal direction. So let's have a look at an example. We've got Fred accidentally drives his car off a cliff. It's a 45 metre high cliff, so that gives us our delta x, our height. How long does it take for his car to hit the water? Okay, so think about the values that we know. So we've got u is 0, a equals what should be negative 10, and we've got x equals 45. So if we substitute in x equals ut, so the ut disappears, we've got x equals a half at squared. So 45 or negative 45 equals a half times negative 10 squared. So we're going to divide 45 by 5, that gets 9 for t squared, or t equals 3 seconds. So time to impact is 3 seconds from that height. So off Fred goes. Splash. Alright, so part B. How far from the base, or what's the range if he was travelling at 25 metres per second as he leaves the cliff? So we have UH equals VH, so constant horizontal velocity. We have A equal to 0 because there's no acceleration in the horizontal direction. We have the time of 3 seconds. So therefore, x equals ut plus a half at squared. The last bit disappears. We've got x equals v times t. So we substitute in. We've got 25 times 3. He actually lands 75 metres out from the base of that cliff. It's not a bad effort, Fred. Okay, so we could line that up. That would be 75 metres to the point of impact. Okay, finally, what's the velocity as he hits the water? So we've got to look at the two components here. We know that the horizontal component doesn't change, so the horizontal component of his impact will be 25 metres per second. Vertical we have to calculate. We know u was 0, we know at, so v equals 0 plus 10 times 3, what should be negative 10, which is negative 30 metres per second, or 30 metres per second in a downwards direction. And then, knowing the vertical component, knowing the horizontal component, we can actually do a vector sum. We've got 25 across, we've got 30 down. That means our resultant vector can be found using Pythagoras' theorem. So we've got 25 squared plus 30 squared equals VR squared. Take the square root and we get 39 metres per second. It should be a bit more than the largest one, but never more than the sum of the two. So if I got a value of 68, I know that I've made a mistake in my calculation. Or if I've got 30 squared plus 25 squared, it's going to be a big number. It means I probably haven't taken the square root.